In previous lesson, we have learned how to deduce the period and the block of an element based on the electronic configuration given. Now next, we are going to learn how to deduce the group of an element based on the electronic configuration. Now, from what we can see here, there are altogether 18 vertical columns. Each vertical column is called a group. So that is why now the group here, there are altogether 18. We number the group from 1 to 18. Okay, the elements in the same group have the same number of valence electrons. So that is why all those elements must have the same chemical properties. So bear in mind, if the elements all have the same number of valence electrons, they will have the same chemical properties. Now, for each main group, we need to know the name of the group. For example, here, group 1 elements are called alkaline metals except hydrogen. Group 2 elements are the alkaline earth metals. Group 3 until 12 are the transition metals. Group 16 are called chalcogens. Group 17 elements are called halogens, and group 18 noble gases. Okay, next we need to know how to determine the group number of element. Okay, remind ourselves, before we can determine the group number, we have to know the block of the element first. Okay, just because there are different methods of determining the group number. Here we can see from here, if the element is in S block, so the group number will be the number of valence electrons. Okay, for P block elements, the group number will be the number of valence electrons plus 10, and so on. Okay, let's look at some examples. Now, remind ourselves, we need to know the block of the element first, then only we can determine the group of the element. Okay, for example here, group 1 elements, how do we know they are group 1 elements? So based on the electronic configuration given here, okay, first of all, we have to check and determine the block of the elements. Okay, if we still remember, the block of the element, we have to refer to the highest energy orbital. If the highest orbital, if the highest energy orbital is S orbital, then the element must be in S block. So in other words, all these elements given here, lithium, sodium, and potassium, they must be the S block elements. So from what we know, for S block element, okay, we need to know the number of valence electrons. The number of valence electrons will tell us the group number. So that is why for all these elements, they must be in group 1. Okay, what about P block elements? Okay, for P block elements, the group number will be the number of valence electrons plus 10. Alright, so let's have a look here. For fluorine, 1s2, 2s2, 2p5. So based on the electronic configuration here, we can say that the F fluorine, it has the highest energy orbital of p orbital. So the F element here must be in p block. Okay, this is the first step that we have to know. Secondly, we have to check the total number of valence electrons. Okay, valence electron, remind ourselves, valence electrons are the electrons in valence shell. The valence shell in this case is shell 2. So in shell 2, 2s and 2p, there are altogether 7 electrons. In order to determine the group number, we need to know the valence electrons. There are altogether 7 for this case. And before we can tell the group, we have to know the F element is in P block. So we know that if we know that the F element is in P block, so we just add number of valence electrons and 10. So the group number will be 17. Next example, aluminium. So from what we know here, the highest energy orbital is p orbital, 3p. So aluminium is in p block. And step 2, we need to know the valence electrons, the total number of valence electrons. Again, the valence electrons are the electrons in valence shell. Valence shell here, shell 3. So that means 3s and 3p are the valence shell. From there, we know that the total number of valence electrons for aluminium is 3. So the group number will be 3 plus 10, which is 13. Okay, for sulfur again, the highest energy orbital is p orbital. So from here, we can say S is from p block. Okay, for p block element, this is step 1. We know that p block elements. Step 2, we need to determine the total number of valence electrons. Valence electrons for the number of valence electrons for sulfur is 6. Why 6? Just because the valence electrons are in valence shell, and the valence shell here is shell 3, 3s and 3p. Okay, from there we can tell the total number of valence electrons. Since the sulfur is in p block, so the group number will be 6 plus 10, which is 16. Okay, next, what about the D block elements? D block elements, the group number is the number of valence electrons. But before we go further, we have to bear in mind the valence electrons are the electrons involved in chemical reactions. Okay, chemical reactions. Now, for example, here scandium. Okay, so for this element, based on the electronic configuration, we know that 3d orbital has the higher energy compared to 4s according to Aufbau principle. Since 3d orbital has the highest energy, now we can say scandium is in D block. D block. This is step 1. Alright. Now, after that, step 2, we need to determine the total number of valence electrons. But for D block elements, the 3d electrons and 4s electrons are involved in the chemical reactions. So that is why for this case, the total number of valence electrons is 3. Yeah, so scantum must be in group 3. Okay, another example here is vanadium. So again, we know that 3D has the higher energy compared to 4s. So again, vanadium is in D block. Now for D block elements, 3D and 4s, the electrons are involved in chemical reactions. So that is why for this case, the total number of valence electrons is 5. And the group number also must be 5 because the group number is the number of valence electrons for D block elements.